Fuel delivery system for hydrogen fuel cell engines. Fuel cell engine systems part 4. Fuel delivery system flow diagram. The same diagram but little bigger in size for your reference. Fuel delivery system. The fuel delivery system regulates the hydrogen that passes through the fuel cell stacks. The system consists of a fuel delivery circuit and a purge circuit. Request. It is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. Fuel delivery circuit. The fuel delivery circuit receives intermediate pressure hydrogen from the motive pressure circuit. Pressure regulator. A pressure regulator at the inlet to the fuel delivery circuit controls the fuel pressure entering the stack module. This regulator receives its feedback signal from the hydrogen inlet to the fuel cell stacks. Ejector. The low pressure hydrogen circulates through the fuel cell stacks using an ejector. New hydrogen enters the ejector where it mixes with and drives the recirculating flow by way of suction. A portion of the hydrogen is consumed by the power generation reaction and the excess is recirculated. The excess hydrogen contains water from humidification of the fuel stream. This water is in both vapor and liquid states since some of the vapor supersaturates and condenses as the hydrogen is consumed. Water separator. This water is recovered by a water separator and is either drained through a water trap to the road or collected for use in the humidification system. Burst disc. A burst disc protects the fuel delivery circuit and releases hydrogen through a roof vent if the pressure exceeds 46 psig. The burst disc contains a rupture disc that consists of a membrane of predetermined thickness. The membrane is often scored. The thickness and scoring is designed to withstand a certain pressure. At pressure greater than the design pressure, the disc bursts, releasing the gas. Rupture discs do not reset and must be replaced once burst. Rupture discs tend to fatigue under normal pressure fluctuations and are therefore prone to premature failure. Rupture point and lifetime are also affected by temperature. Purge circuit. The purge circuit is linked to the fuel delivery circuit and permits periodic fuel discharge to atmosphere. This occurs periodically and automatically in order to drive out any accumulated water or residual non-fuel gases. Purge solenoid valve. A solenoid valve controls the gas discharge. This solenoid valve remains open whenever the engine is shut down and allows the motive and low pressure hydrogen circuits to vent when not in use. This prevents a vacuum from building up within the fuel delivery circuit, since any residual hydrogen would slowly react within the fuel cell stacks while the engine is off. Hydrogen diffuser. The escaping gas is expelled through a roof-mounted hydrogen diffuser. Residual water is either drained through a water tap to the road or collected for use in the humidification system. The diffuser consists of a pair of tubes that pass in front of a ducted fan. One tube carries the purged hydrogen and has a series of holes that release the hydrogen into the forced air stream. The second tube carries coolant from the bus cooling system, which warms the discharge tube to prevent ice formation. The fan dilutes the hydrogen with sufficient air so that it is non-flammable. Request: it is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा।